My name is Rick Haskell, and today we're going to take a look at a couple of videos with respect to break-even analysis. As we look at these videos, we'll consider the variables in a simple break-even analysis equation or construction. We'll look at the condition of break-even, where we have zero profit, such that total revenues are equal to total costs. We'll consider what total revenues are, the price of goods sold times the quantity of goods sold. We'll look at what total costs are, the combination of fixed costs and variable costs. And then we'll look at an equation that will help us identify the number of units that a firm may need to sell to reach this break-even condition. And then finally, we'll relax some of the condition on that equation to think about when we're trying to achieve a specific target profit other than zero. So to start this, let's go ahead and think about the variables. The variables begin with total revenue, and total revenue is typically expressed simply by TR, and it just means the total revenue for the firm. In this case, we're going to think of a very simplified firm that produces and sells one product. Maybe we'll call it shoes. And there will be one price that it sells the shoes for, and one quantity of pairs of shoes that are sold. So the price then, which is typically P, is simply the price for which the good is sold, in this case shoes. And the quantity, or Q, is the number of shoes that are produced and sold. And we're supposing in this environment that the number of units of shoes that are produced, pairs of shoes produced, is equal to the number of pairs of shoes that are sold. So we have total revenue, but we also have to think of total cost, which is TC. And total cost is the sum of total fixed costs and total variable costs. So we're going to talk in a few minutes about what a fixed cost is, or a FC. We'll look at what a variable cost is, and then the sum of those are, not surprisingly, total fixed costs and total variable costs. We might also have to think about a construction of average fixed costs and average variable costs. And those values would be, for average fixed cost, the total fixed cost divided by the quantity of shoes sold, in this case, or the total variable costs divided by the quantity of shoes sold. And then we'll think about profit, but we're going to use the economic convention here such that profit is represented by the variable pi. And that's a lowercase pi in most cases. So let's consider this scenario when total revenue equals total cost for break even. So when total revenue equals total cost, just as I've indicated here, we have break even, or when total revenue minus total cost equals profit, and profit is equal to zero, then we also have break even, just as I indicate here. However, we have to consider when total revenue is greater than total cost, or total revenue minus total cost is greater than zero, then we think of that as some profit, and it's positive, of course. Similarly, when total revenue minus total cost is less than zero, which is the same condition as when total revenue is less than total cost, then we still have profit, it's just that it's negative. Let's think a little bit further about total revenue being price times quantity. So in a simple environment, as we might think of where we have a firm that produces and sells one good, we're going to call it shoes in this case. And it sells each pair of shoes for a particular price, which we'll call PS. And it sells a quantity of shoes, which we'll call QS, such that PS times QS equals total revenues for shoes. So if the price of a shoe, PS, is $100 a pair, and the quantity of shoes is 2,000, then obviously 100 times 2,000, or the price of the shoe times the quantity of the shoes, will be 200,000, and that would equal the total revenue of the shoes. What if, though, we have an environment where there's more than one type of good, where we have a number of different goods being produced, sold in the same environment? Well, let's think about this. I'm going to use as an example maybe a simple taco stand for a minute then. I think most of us have been to a taco stand, and let's say in our taco stand that the price of tacos, or PT, is equal to $2.99, and the quantity of tacos, or QT, in this case, is equal to 97. And we have burritos, where the price of a burrito is equal to $4. The quantity of burritos sold to 230. And we have some soft drinks, where the price of the drink is equal to $1, and the quantity of the drinks is equal. Now we can think of total revenue, which is PT times QT plus burritos, or PB times QB, plus PD for drinks times QD for the quantity. Or in this case, $2.99 times 97 plus 4 times 230 plus 1 times 227. That then should equal 293 cents plus 920 plus 227 for a total of $1,430.03.